What exactly really broke through though? The first one that broke through is the reliable logical qubits, so that as you can increase the code distance, the logical error drops, defining condition for scalable. Even Microsoft and Atom Computing have created a 24 logical qubits is a level 2 resilient milestone and operated with 28 evidence QAC. Hello everyone, welcome to today's Founders Decoded. This is a special episode. Generally we interview founders, but what fascinated me is the breakthroughs that have been happening past couple of weeks in quantum. And I just wanted to summarize what it means and what is the future scope of this. So in the last year itself, quantum jumped from lab demos to error-corrected logics on commercial machines. Microsoft and Quantium ran 14,000 logical circuits shots with zero errors, Google with below threshold surface code memories, and QEra with magic states at the logical level. Wall Street noticed. But what do these milestones mean and unlock this year, next year, and beyond? Today we'll break it down, including stocks, apps, finance, security, materials, energy, the truth about NP-hard problems. So why do I care about quantum first of all? So I love quantum. Basically, I have done a lot of courses in RF and quantum, which I never got to show. What exactly really broke through though? So the first one that broke through is the reliable logical qubits, so that those 14,000 zero-error circuits is a level 2 resilient milestone. In short term, dependable small logic programs can be executed. And in the long term, if they ramp up, this is more towards the fault-tolerant workloads. And the second one is below threshold error correction. Google demonstrated two below threshold surface code memories, and which is distance 7 and distance 5 with real-time decoding. As you can increase the code distance, the logical error drops, the defining condition for scalable fault tolerance. The other one is first ever logical layer distillation. This is done by QEra and Harvard with Harvard or MIT collaboration with first logical layer with neutral atom processor. So which is basically like making non-Clifford resources inside error correction, which is again fuel line for universal fault tolerant. Other steps that happened were neutral atoms at the logical layer. Even Microsoft and Atom Computing have created a 24 logical qubits and operated with 28 evidence QAC. Evidence quantum error correction progress isn't just limited on hardware attack. So, which is good. That means people can start developing algorithms and whole machine quality is up. Quantium H2 had a quantum volume of 2 power 25 operations, which is like 33.6 million operations happened once. And IonQ hit 64 on tempo. These are just like the plumbing metrics that correlate with usable circuits and annealing. When you think of annealing, D-Wave comes into mind. So which is basically like D-Wave started with annealing beyond classical computation, but for a quantum simulation tasks. Specialized, but real. And the scaling issues currently are solved by PsiQuantum, where it raised 1 billion of Series C and broke ground in Chicago and Brisbane facilities, utility scale on photonic sites with data. What does all these breakthroughs? It's like I told a lot of stuff, but what does these breakthroughs mean? Currently, you can run short circuits inside error correction and fewer retries and clearer results, which basically means you can do smaller algorithms like Clifford gates and all, which breaks through the potential of subroutines of chemistry fragments, financial amplitude estimation, and secure protocols inside the logical layer. So it's not ready, it will be ready. Below threshold surface code, currently we use logical memories and small logical circuits with real-time decoders. But later, reliable multi-logical qubit programs where the scaling improves fidelity. Why are logical qubits important, if you ask me? Logical qubits basically are error-free qubits, and they are built on top of qubits. And what does it solve? Kind of solves, ideally, a fault-tolerant system, and which kind of is like when you can scale a lot, you can do a lot of things like chemistry or like financial kernels at a huge scale once the scaling is finished. And logical magic state distillation, this was done by QERA. End-to-end distillation can be done in the logical layer, and higher throughput latencies would be the next breakthrough there, makes it full-time quantum computing feasible. So there will be several applications where chemistry, simulation, theoretical tasks, a lot of, you can analyze different things which involve solving NP-hard problems, and neutral atom logicals, which is done by Microsoft and Atom. So currently you can host a lot of modalities in quantum error correction. Boosting scale, you can boost it on scale. The next breakthrough there would be hundreds of logicals with parallel operations. Until now, the parallel operations was not done. So once you do that, it kind of solves like larger workloads on materials and energy models. Again, you could still use it for finance kernels and healing, and which is beyond classical, but it is a hybrid. Think of it as a hybrid, having both cases on optimization and simulation classes. So the next breakthrough there would be bigger graphs and noise control. So more industry-sized instances. So solves logistics, supply chain issues. You could do energy grid operations, portfolio heuristics. So what can all these breakthroughs can help today and soon? Currently, like IBM and Moderna are using a hybrid quantum simulation to model 60-MT mRNA secondary structure on lower error Heron hardware. It is one of the largest quantum run to date. It is still at a research scale. Like now, you cannot do any drug discovery, but you can soon discover that. You can do soon drug discoveries, and a lot easier, a lot faster. And on financial side, let's talk. Portfolio and risk are the most important things. When you reduce errors in quantum qubits, then you can understand several factors on financial. So like bond trading, and also like even Vanguard explored utilizing quantum for hybrid portfolio construction at huge scales. So 401ks are getting managed by potentially in future by quantum computers. Analysts are cautious, but it is heading to the clear direction though. And there is still not a huge advantage from it, but once it scales and it speeds up the reliability. The next is security. Currently, every bank and everything uses Shor's algorithm for generating OTPs, tokenizations, even crypto uses Shor's algorithm. It cannot be cracked by classical computers because it's hard. And with quantum computers, you can decode them easily. So we need a lot of new algorithms on security so that quantum cannot also solve this. So this is a challenge for mathematicians. And currently, public for this, ORCID from UK is trying to decode, and which had a pilot in September 2025. So I still don't know what the result is. So I'll keep you posted. And materials and energy. So with all this quantum applications, you could think that resource estimations, let's say how much oil we have, or like chemical simulations that are to the point, hundreds of thousands of logical qubits needed for that, heavy decade budgets are required for that, depending on system algorithm. So currently what we have is subroutines with good classical workflows. Let's come to stocks and what happened in those breakthroughs, what each company solves next, and where could the potential be. So let's start with Rigetti. So there were 2 purchase orders for Novera systems on end of Q3, September, which is the September 30th. And Rigetti also made a contract with AFRL with Q4 conducting quantum networking. So people are showing interest on developing applications or utilizing in different areas. And as a consumer, Do I really need a quantum computer at my home? Not yet. We don't have a two-story building that could support that. Or you can have a smaller photonic system, but still, it's not ready. So, next breakthrough could be from them. They could also achieve below threshold logical memory like Google. And also like logical gates can be demoed in Rigetti hardware. And what it would solve is, once you can scale, finance, security, materials, and energy. So, which is good. I'm optimistic. And next in our list, IonQ. What they do is, it's trapped ion based technology. And why there was a boom in the stock on Tempo, they got an AQ64 rating, which is deeper, cleaner circuit for app style workloads. What it means is like you have better heuristics in POCs. And what could their next path be? Again, public logical qubit. And one thing I actually noticed that IonQ has acquired 4 or 5 companies in this year alone, where it used the capital from stocks to purchase those. One of it kind of struck me as it's a California-based space company, Capella Space, if I recall. If I'm wrong, it's okay. So the interesting idea is maybe you could have an entire quantum computer or quantum network. Once it scales, you could have it in space, and you could set up a secure network. How currently we have everything in classical channels like internet and everything. So, which is interesting. And next is D-Wave. So this is the last breakthrough was starting of last year in March, where they showed a beyond classical performance, but it was a simulation of quantum task. So the performance exceeded classical, and what it means is there is a high usable advantage instead of using just classical computers. So what it means is there is a highly advantage now for right optimization and sample problems in hybrid solvers. What could be next? There could be advantage to graphs with lower noise, so that can wider industry-sized instances using like portfolio rebalancing or route or schedule optimizations. And Google, you're doing good by the way, but still there could be a potential where a traffic solution can be reducing traffic at different places with quantum computer. That could be application. Grid unit commitment materials using these models that can be developed and explored. Who knows? You can be the next one to find a new material, synthetic material that could solve a lot of things. So let's see how it goes. And Qubits, Quantum Computing Inc. They have more coverage on photonics roadmap. So it is still a very volatile microcap, but why are people investing in it? When I started looking into it, most of the people think that manufacturing and photonics potential is there, which is true. There is a huge photonics potential where you might not need 2 or 3 floor sized quantum computers, but it's still theoretical. So theoretical and some experimental, but technical proof points are still forming. Next would be photonic computing and sensing, or non-paid deployments where like you and I can try it. So let's see when they would come up with for everyone to try. What can be done with this? You can do a quantum safe communication integrations, opto heavy simulations, because like photonics and sensing for energy or materials. If you see some commonality or distinctiveness, each company is solving a different aspect of the problem, and each technology is solving a different problem in quantum. So that means I think all these companies put together could solve quantum computing, quantum computer, and NP-hard problems. So quantum is not just solving magic NP-hard oracle. So the evidence comes from complexity theory of BQP, what efficient quantum computers can solve. which does not include NP complete in general. So you do get some speed up on solving, let's say, even just analyzing coffee in classical computer might take like hundreds of years, whereas in quantum computer, it could be done in 4 minutes. You do get a lot of speed ups, which can solve Grover search, polynomial ones, factoring sure, but not a generic collapse of NP hardness. So what is realistic? Let's keep our thinking hats on. Specialized exponential or super polynomial gains in simulation, which can lead to breakthroughs in physics or in chemistry. Once we have fault-tolerant quantum computer and magic state throughput. The speed matters and the optimization matters. So all this can be done by different quantum computers. Let's talk what's next and what you need to watch about. So we think there will be more logical layer experiments going to happen, and hybrid might win in optimization and material subroutes, and where D-Wave is showing huge advantage on it. And logical qubits count because it's error-free qubits, technically. And below threshold operation, which is done by Google, but other companies will be getting through that, and the magic state. We're almost there. Later, you could have around in the next 2 years itself, 2 to 3 years, we could scale qubits into like hundreds or thousands with good fault tolerance and good distillation and robust distillation, which has a lot of app advantages, which can be chemistry, like binding energy, catalytic step. And in finance, you could do Monte Carlo simulation. This is done by T-Gate for full chemistry accuracy. And for crypto or security timeline, still Arcade is trying. So let's see. That could be next. Security and crypto timeline. Currently, the company Arcade is trying to solve it for Shor algorithm, decoding Shor, but it's still in the pilot phase now. So let's see. And hope they'll get new algorithms. I'll keep you updated on the algorithms. Finally, 2019 gave quantum supremacy, which is 2025 when reliability came in. I think next few years is about engineering, scaling this, building distillation facilities, and moving, providing dollars and outcomes in finance, security, materials, energy, and maybe I should come up with an acronym and drug discovery. Markets will swing, but the physics won't. So, peace.